Deck haunches are commonly used on both pre-stressed concrete and structural steel girder bridges. The haunch is the area between the top of a bridge girder and the bottom of the concrete deck that helps maintain a uniform deck thickness. A recently completed Center for Transportation Research project conducted full-scale laboratory testing and developed computational models on a wide range of haunch details for both pre-stressed concrete and structural steel girder bridges. This work has resulted in guidelines for analyzing, designing, and detailing haunches having different heights and reinforcement detailing, improving the effectiveness of current TxDOT detailing practices.
The haunch is necessary to help keep the deck and the beams acting together. And so this research was all about how we reinforce that haunch area to make it so it all works together.
The haunch is actually the connection, generally it's the region over the top flange or the top of the girder to where it connects to the concrete slab. And a lot of times we'll end up having maybe an 8-inch thick concrete slab that we use for the bridge deck, but then due to changes in geometry of the girders along the length, a differential camber between adjacent girders, a lot of times there'll be a little bit thicker region over the top of the girders. Most standard haunches in both steel and concrete bridges are usually of the order of maybe 0 to 3 inches. In some cases where there might be an extreme geometry issue with the bridge, some cross slope issues across the width of the bridge, they may need to have a thicker haunch. Some cases there'll be construction problems that lead to where they have to have a much thicker haunch. So when we talk about tall haunches here or extreme haunches, we're talking about haunches in the range of about 5 to 15 inches, significantly higher or larger than what we would use on a standard haunch. A lot of times when this happens, if it's a construction problem, the girders are up, the contractor's trying to build the bridge. We're trying to minimize the impact on the traveling public, but all of a sudden you have this problem that needs to be fixed, and you have to kind of come up with a detail that allows you to have this extreme haunch. And there's some questions about how it impacts the strength of a composite concrete or composite steel girder. And that's what we were trying to focus on here. This project, it was relatively unique in that a lot of times we'll say there's a steel girder bridge project or a concrete girder bridge project. This considered both steel and concrete girders. And in order to study the behavior, we really needed to do some full-scale testing. Okay, when I say full-scale there, I mean trying to test reasonable sized girders along with the geometry that would be existing in these haunched regions. So they consisted of I'll call them full-scale laboratory tests, doing what we call a push-out test, where even though we're simulating a girder, we would actually do our tests in a large frame where we subject large shear forces between the simulated deck and the simulated girders on them. So we did extensive laboratory tests on both steel and concrete, girder systems, and then we used that data to validate computer models that allowed us to then look a little bit more at the wider range of geometries using computational models.
What we found, very interestingly, is our current practice can be expanded to deeper haunch levels and with very minor modifications to our existing standards. And then they also provided a bit more guidance onto what other things we can do that would achieve the same purpose.
You get these problems in the field and you want to have a solution. And this is a relatively, common problem where things come up and the geometries suddenly necessitate maybe increasing the haunch above what you normally would have. I think this research provides a good solution to those problems and hopefully trying to avoid, any delays and so on that may end up impacting the construction schedules.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.